Okay, so let's look at rational expressions. So we have a rational expression here. The idea is that you have like a polynomial on top divided by another polynomial. That's the concept of a rational expression. And we kind of want to get information in terms of graphing it and what types of restrictions they're going to be. So it's usually easiest if we're in a type of factored form. Right now, though, we're not. What form is this? This is like a standard form.
Yeah.
Same with this one. So we're going to change these standard forms into factored forms, and that's going to give us a lot more information about what types of restrictions we're going to need. So let's kind of focus on the top here. I have an x involved in all of these, so we can common factor out the value of x, correct?
Yeah.
So we take x out, I'm going to make that in red, and this would be left as x squared plus 3x minus 10. Essentially, you've subtracted an x value from the exponent from each of those terms. On the bottom, we can do the exact same thing. There's an x on each of those, so we can common factor out x again, and you're left with 2, subtract, and just the value of x. Now, we from here can already start to like eliminate stuff, but be aware that for restrictions, we actually want to state restrictions before we do any elimination.
Yeah.
Okay. So these two things here, for the restriction on a rational function, the bottom of a function, this, cannot be equal to 0. If it's equal to 0, then it doesn't exist. So on the side, we're going to do a little thing here. We're going to say, and think of these as almost like two separate terms. I'm going to say, we'll do it in green here. X cannot equal 0, so that was one bracket, and 2 minus x cannot equal 0. Well, one of them, there's nothing we need to change. X cannot equal 0, we got that. For the other one, we're going to bring that 2 over, so we have negative x cannot equal negative 2, which means positive x cannot equal positive 2. So your two restrictions...
That's very
Whoops, that's okay. Let's go back. I want it to be just the top. So x cannot equal 0, and x can equal 2. So we got those two out of the way. We can start to eliminate. Point it right down if it's
I'm
too
trying to
bright.
like move it away from you.
No, it's okay. So those two x's eliminate, right? They essentially cancel out and they create a 1. But we're still technically in a type of standard form here. So we want to take this farther. We want to put this into a factored form. This is already in a factored form. So we're going to rewrite it again. This part here, I can use a product sum to factor.
Yeah.
And it looks like we're going to get x plus 5 and x minus 2 would be the factored form of that standard form there. And then we have 2 minus x. So we're looking at this, and these two look pretty similar, but they're actually not quite the same.
Yeah.
So what we're going to do here is I'm going to put them in the same order. I'm going to put this variable in front and this constant at the end, just so we get a better visual of what we're looking at here. So we have x plus 5. So I really haven't done anything but change the order of our denominator here, which is fine as long as I keep the signs the same. So if you notice, the x has a negative in front of it, so it's a negative x. And the 2, if there's nothing there, it's assumed it's positive. So what we have here is we have a positive and a negative, and this is a negative and a positive. So they're not quite the same at the moment. But there's something else I can do. I can common factor out negative 1. If I common factor out negative 1 from here, we're going to end up with operations that are the same on the bottom. So when we do that, the top's going to stay the same. We have x plus 5, x minus 2. And on the bottom, we're going to common factor, so I'll write it in red again. Negative 1 has come out, so think of it as its own term. And we have x minus 2. Now we have a set of brackets that are the same. These cancel out and create a 1. And you have x plus 5 divided by negative 1. You could leave it like that.
But it doesn't look that...
Yeah, the common way to make it a little simpler, a little more... not so expanded form, it's just put the negative in front of the set of brackets. So you have x, negative x plus 5. And then you could then even decide to distribute your negative here. So if you distributed your negative, you would end up with negative x, negative 5. Or you can write it like this with the negative in front of the x plus 5. Both of them are both technically correct. Okay.